Hi, my name is Kenji Shimizu from Entity Network Innovation Laboratories. This presentation is about what type of wireless access virtualization using Open Button. I'm very sorry about not showing the forum, but I'd like to present this work at this forum even in this remote presentation. I'd show a background. This chart shows the accumulated number of wireless access technologies emerged in the recent years. The x-axis shows time and y-axis shows accumulated number. And the triangular especially shows the wireless access protocol for IoT services. It means that in the future, various type of wireless access technologies such as NB-IoT, LoRa, 11AH, etc. will appear and remain to support various kind of future IoT application. The word remain means that if the IoT devices are deployed in field, we cannot change the wireless access type of each devices because it's difficult to bring back the devices and change the communication module. And considering especially unlicensed wireless system, telecom operators may need to deploy and manage various wireless access under their quality control to guarantee each QoS. This is justified when think of the quality degradation of 2.4 GHz Wi-Fi access. To accommodate lots of wireless access technologies in the telecom operator's network, we have to deploy multiple kind of access points and have to manage QoS for each wireless technologies. The word here, B2BX model, is a target business model of entity group, which means that entity as a left B provide the support for the center B by various value via telecommunication. Thinking of this bits X model as a left B, to overcome such future requirement, we have to provide a network with lots type of access points and quality control. It means that it leads to the vast increase of network equipment and complexity of quality management, resulting in increase of CapEx and OpEx. This picture shows telecom operators network should support multiple type of wireless access technologies. This shows LoRa, Zigbee-like protocol, ITS, and 11AH. This is just an example of various wireless access technologies. This slide shows our vision of wireless access virtualization. It deploys wireless access slices on demand during required time and place based on IoT service providers' requirement here. For example, LPWA LoRa on demand, cellular Wi-Fi on demand, and DSRC on demand in a specific time and place based on this requirement. The key component to achieve this vision is design and management engine for wireless accesses to select base station and wireless protocols and another component is multi-purpose radio infrastructure. This presentation is mainly about this multi-purpose radio infrastructure. Multi-purpose radio infrastructure is like a network sharing among various types of wireless access technologies. This slide shows three types of sharing like site sharing and MORAN. MORAN is a multi-operator radio access network and MOCN is a multi-operators core networks. We have extended this MORAN like architecture so that it supports multiple wireless accesses. To achieve this, each wireless access technologies have to be split into baseband software and multipurpose radio hardware. Like a centralized LAN and cloud LAN, all software part of each wireless accesses are located in a centralized and virtualized infrastructure like a BBU, which is a baseband unit. And about hardware, we utilize multipurpose SDR hardware located in a RRH-like site. RRH is a remote radio head. This slide shows a picture of what I have just said. The very right side here shows the existing wireless access deployment. The baseband processing of each wireless access technologies are softwareized over the virtualization layer, and hardware part is deployed in a multipurpose radio hardware. For this hardware, I utilized SDR, which stands for Software Defined Radio, because of its flexibility and multipurpose characteristics. It fully utilizes existing NFV technologies, and by utilizing NFV model, we have just tried to manage all these end-to-end resources, including radio, and offer various kind of wireless access on demand. This slide shows the relation between NFV architecture and wireless access virtualization. The well-known basic architecture of NFV are shown in the right side here. As you can see, it does not have radio resources in it, and because of this, there is no manager to control radio resources. So we have just proposed 3 procedures addition to the basic architecture. One is the interface to dynamically configure RF frequency, sampling rate, and RF gain of a radio hardware by this design and management engine of wireless accesses here. And second, lifecycle management of each VM, which executes softwareized wireless baseband processing of each wireless access technologies here. And third, because the software part and the hardware part of each wireless access technologies exist in different nodes, it needs to connect between software and the hardware part here. This is the procedure of prototypes. We have implemented our prototype using open source software such as OpenStack and GNU Radio, which is software-defined radio platform, and NFV manual compliant orchestration software, which name is OpenButton, just manages all the functions to control when and where required wireless access slices are deployed. The procedure is like this. Design and management engine requests the activation of software part of wireless accesses as network service via Etsy network service description 1. Then OpenButton talk with OpenStack, which is working as a VIM to deploy VM via its lifecycle management. The VM exists. The VM is for Wi-Fi, Zigbee, and LoRa, 3 of access technologies. Then via EMS, talking with each VM, OpenButton send required softwareized BB program. Then let them execute and configure the required wireless software in each VM. Next, via newly defined API, it configures frequency, sampling rate, and TX-RX gain by way of radio infrastructure manager. In the end, it's connect between software part and hardware part of each wireless access technologies by changing the network routing between VM software part and hardware part, it can easily offer other slices of different wireless access technologies on demand. For example, the connection between red box and hardware, it provides Wi-Fi. Then changing the route between blue box and the hardware, it provides a LoRa, something like that. This slide shows a screenshot of Open Button Management Interface and NSR, Network Service Record, and OpenStack, which boot up each VM, executing software part of each wireless access technologies. And bottom ones here are screenshot from GNU Radio. Left is Wi-Fi, center is Zigbee, and right is LoRa. Although it does not exist simultaneously, we can easily change between these wireless access technologies in a single hardware. All the procedure is managed via Etimano framework. It's thanks to open button compliancy with Etimano. We would like to start activities in standardization and other community in this field. Currently, there's computing resource management for BBU manager and network management of frontal manager in SNFV. Then we would like to add another radio resource manager here, which controls base station radio resources. This is conclusion of my presentation. We proposed one candidate architecture of efficient wireless access network targeting heterogeneous environment. Future works are standardization of network management on wireless access virtualization and feasibility study of optimal wireless access slice deployment. We would like to continue this work discussing with lots of people. So if you're interested in, please contact this address. Thank you very much.